right, so hopefully the first time we did 8.1 went well, and we got this process down pat. So let's jump right into 8.2. It's 1/27 is today's date. And we're going to look at special right triangles today. So we're going to be able to use properties of 45, 45, 90 triangles and 30, 60, 90 triangles. So certain right triangles have properties that allow you to use shortcuts to determine the side lengths without using the Pythagorean theorem. So we are going to learn what those shortcuts are today. And then we're going to also add them to our Ames reference sheet. So these ones I'm not going to expect you to memorize. So let's take a look at the 45, 45, 90 triangle theorem. So in a 45, 45, 90 triangle, the hypotenuse is rad 2 times as long as each leg. If it's 45, 45, 90, we know it's an isosceles right triangle because these two base angles are congruent. Therefore, the legs in this right triangle are also going to be congruent. So in order to find the legs, the hypotenuse is the leg, whatever that leg length is, because it's going to be the same on both legs, times rad 2. So our cheat sheet is hypotenuse equals leg times rad 2. So let's do a quick algebraic proof of this. If we have a right triangle, an isosceles right triangle, and we define the legs to be x, and the hypotenuse to be y, since it's isosceles, we know these base angles have to be congruent. One of them is 90, the other two together are complementary, so they add up to 90, so each of them has to be 45. So if we take a look at the proof, we can show that a squared plus b squared equals c squared is what we're trying to show. But in this case, a and b are our legs, so x squared plus x squared equals y squared. I combine like terms and I get 2x squared equals y squared. Take the square of both sides and I end up with x, the square root of x squared is x, times the square root of 2 is equal to y, which is our hypotenuse. So now we can use that pretty handily in lots of different theorems. So I can use hypotenuse is equal to leg rad 2 and substitute in the pieces I know. So x is equal to leg, which is 2 rad 2, times rad 2. X is equal to, we know that a radical times a radical that are squared just pulls that piece out. So we end up with 2 times 2. So x is equal to 4. Let's try this one. We know it's a right triangle. We know these are congruent. So we know that this has to be a 45, 45, 90 triangle. And we know in a 45, 45, 90 triangle, the hypotenuse is equal to the leg, rad 2. We don't know what the hypotenuse is. We'll call it x is equal to the leg, 4 rad 2 times rad 2. Rad 2 times rad 2 is just 2, so 4 times 2, x is equal to 8. Okay, let's try another one. That was finding the side lengths. The process for finding the leg lengths is the same. We know these are congruent, so we know we have a 45, 45, 90 triangle, so we set up the cheat sheet. Leg times rad 2, substitute in the pieces I know. 9 rad 2 is equal to the leg, which is x, and carry down the rad 2. I need to divide both sides by rad 2. Handy dandy, those cancel out. X is equal to 9. When your hypotenuse is something rad 2, we know the hypotenuse is a leg rad 2. So I could automatically jump to the leg equals 9. Another shortcut. If not, set up your equation, do your algebra, you'll get there anyway. Let's try the next one. I know my sides are congruent in this right triangle, so I know it's a 45, 40, 90. I know hypotenuse is equal to leg rad 2. Hypotenuse is 2. leg is x rad 2. Divide both sides by 2, rad 2, and I'm left with x is equal to 2 over rad 2. I am not allowed to leave that radical in the denominator, so I need to multiply by rad 2 over 2. We know then that x is equal to 2 rad 2, and rad 2 times rad 2 is 2. But that can simplify down to rad 2. Okay? You're going to pause your computer, try the next two, and then press play. Okay, you should have gotten x is equal to 6 rad 2 and x is equal to 12. Be sure you get in the habit of taking a look at your triangles to identify that they are an isosceles right triangle, therefore 45, 45, 90 applies. Then you substitute in your pieces and off you go. All right, the second theorem in this section deals with 30, 60, 90. I no longer have isosceles right triangles. I have right triangles specifically with a 30-degree angle and a 60-degree angle. Again, they're still complementary because it's a right triangle. They sum to 190, or 180. I already have 90. So the other two are complementary and have to sum to 90 as well. So in a 30, 60, 90 triangle, the hypotenuse is twice as long as the short leg, and the long leg is rad 3 times as long as the short leg. So it's all in reference to the short leg. Now remember, hinge theorem tells us that the shortest leg is across from the smallest angle. So since 30 is the smallest angle, across from that is going to be your short leg. Your 60 is the longer, or the bigger angle, so you're going to have your long leg across from your 60-degree angle. And your hypotenuse, as always, is across from your right angle. So to put this in abbreviation, we know the hypotenuse is twice as long as the short leg. So we're going to do short leg times 2. Let's make a note over here. SL equals short leg, just for abbreviation. We also know that the long leg is equal to the short leg rad 3. And LL stands for long leg. Okay, so let's apply them. Now remember, you need to first make sure that you have a 30, 60, 90 triangle. If you do not, this method does not work. You have to go back to your Pythagorean theorem. So if you have a 30, 60, 90 triangle, you know that your hypotenuse is equal to your short leg times 2, and you know your long leg is equal to your short leg times rad 3. So I'm just going to set up the equations first, then substitute in the pieces I know. I know my hypotenuse is y is equal to short leg is across from the smallest angle, so x times 2, or 2x. This doesn't help me because I have two variables, so I need to go solve for one of these and then substitute it in. So let's see if the long leg helps. The long leg is across from the larger angle, so my long leg is 8, equals my short leg we defined as x rad 3. This one has one variable, so I can solve for x. I'm going to divide both sides by rad 3. And I get x is equal to 8 over rad 3. We need to rationalize that ratio because we cannot leave it with a radical in the denominator, and we get 8 rad 3. That's my x, or my short leg. So now that I know what x is, I'm just going to substitute it in. Y is equal to 8 rad 3 over 3 times 2, which is equal to 16 rad 3 over 3. I would check and see that if I could simplify 16/3, and I cannot, so I will leave my long leg equals 16 rad 3 over 3. Okay, pause your video and try the next one, and then check your answer. Okay, you should first identify your short and long legs, make sure you have a 30, 60, 90 triangle, and then set up your equation. Figure out which one you need. I don't have a hypotenuse, so I'm going to use the long leg formula, and I find x is equal to 6. All right, let's do some application problems. A high school softball diamond is a square. The distance from the base to base is 60 feet. To the nearest foot, how far does the catcher throw from home plate to second base? So I'm going to draw our field, and it tells us it's a square, and it tells us between bases is 60 feet. Since it's a square, I know all the sides are congruent, and it wants me to find how far the catcher throws from home to second. So I'm going to call that X. But if you take a look, I have a diagonal that creates two isosceles right triangles. So this must be 45 degrees and this must be 45 degrees. So I can use my special 45, 45, 90 to easily find X. If I didn't remember that, I can still use the Pythagorean theorem because I have a right triangle. So we know that the hypotenuse is equal to the leg, rad 2, for a 45, 45, 90 triangle. Substitute in the pieces I know. In this case, X is my hypotenuse across from the right angle. My leg is 60, and it's times rad 2. Feet. But it says round to the nearest foot, so we're going to use our calculator. 60 rad 2, oops, gives us approximately 85 feet. Okay. An artisan makes pendants in the shape of equilateral triangles. Equilateral triangles, we know, are regular triangles, which means I have congruent sides, congruent angles. If those angles are all congruent, then we know they have to be 180 divided by 3, which is 60. The height of a pendant is 18 millimeters. Now remember, a height is an altitude from the vertex perpendicular to the other side. That is what height is defined as in a polygon. So my height is the altitude, and it is 18. I now have a right angle for this right side, a 60-degree angle, so this must be a 30-degree angle. So I know I have a 30, 60, 90 triangle. It asks me what is the length S of each side of the pendant nearest tenth of a millimeter. So I'm looking for S over here. So I'm going to quickly redraw this so I can see better. I got 18, I've got S, and I don't know what that piece is. But I do know that X is really just half of S. This is 60 degrees, so across from 60 is going to be my long leg. S is my hypotenuse, and so X is across from the 30, so this must be my short leg. So let's write down our two equations for our 30, 60, 90. I have hypotenuse is equal to 2 times my short leg. And I also know my long leg is equal to the short leg, rad 3. So substituting the pieces I know. My hypotenuse is just my side, is equal to 2 times my short leg. My short leg in this case is X. So I need to solve for either the side, the hypotenuse, or X before I can finish this equation. So I'm going to try my long leg. I know my long leg is 18 because it's across from the 60-degree angle. Short leg is X, rad 3. Now I only have one variable and off I go. So I know I have to divide both sides by rad 3, so I end up with 18 divided by rad 3, which is equal to 18 rad 3 over 3. I check to see, does 18 divide by 3, and I say yes. So X is equal to 6 rad 3. We know that S, or my side length, or the hypotenuse, is 2 times X. Well, that makes sense because we already knew we divided our side by half when we drop the altitude in. So my side, or my hypotenuse, is equal to 2 times 6 rad 3, which is equal to 12 rad 3, which is approximately 12 rad 3, 20.8 millimeters. Okay, so you pause your video, try the next two, and then check your answer. Okay, you should have gotten approximately 141 feet for your diagonal in your garden, and you should have gotten 15.6 millimeters for the height of your pendant that has side length of 18. If you did not get these, make sure you're jotting down your questions for class tomorrow, and we will see you then.